How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at some practice problems about 20.7 batteries. So describe the construction of common batteries and explain how they function. So first question, what is the anode in an alkaline battery? So these are like the non-rechargeable batteries that you see everywhere. And the short answer is zinc. Zinc is the anode. So if we take a look at the construction of an alkaline battery, we have one end, a positive connection up here. We have the negative terminal down here. We have a protective cap. But what's really going on the inside is we have some manganese oxide. MnO2 is the cathode. And then we have the zinc anode. So we have zinc losing electrons, becoming zinc plus 2. And we have the manganese oxide being reduced. So in order for the electrons to get from the zinc powder to the manganese out there, it needs to flow out of the negative terminal, go through whatever you're powering, maybe it's a smiley face flashlight, and then enter the positive terminal so that now it's in connection with the manganese. And that's how batteries work. Number 2, what is the cathode in a hydrogen fuel cell? So we know hydrogen fuel cells have to do with H2 and O2, and they react to give us water. Right? This is not balanced, but I guess I could balance it, make everybody happy. So what's going on here? What's the cathode? Well, we know the cathode is where reduction occurs. So what's being reduced? Well, the oxygen is. It goes from O to 0 to become O minus 2. And that is reduction. So the answer is oxygen, or specifically O2. All right. Cool. Number 3, in a lead acid battery, the electrodes are consumed. What is the anode in this battery? What I like about lead acid batteries is that it's kind of cool how they end up with the same product. They all, like the anode and the cathode, both make the same thing. But at the anode, we're starting with lead metal. We're reacting it with some sulfuric acid going on, and we're making PbSO4. And then, there's other stuff. This isn't balanced. But at the cathode, we're starting with a PbO2, where the oxidation number for lead is +4, and it's going to get reduced, and eventually it makes PbSO4 as well. So this is what's happening at the cathode, where reduction is occurring, but this is what's happening at the anode, the PbO2. Let's see, what is it saying? What is the anode in this battery? It's the Pb. PbO, the lead metal, gets oxidized to become PbSO4. So there you go. 4, what word is used to describe when iron is coated with a thin layer of zinc to protect against corrosion? And it's it wants the word. Why am I just saying? Galvanized is the word that describes that. And the reason that they use zinc is that it's more active than iron, meaning it's more likely to oxidize. So what happens is if I have like this iron nail, let's say, but I coat it in zinc, well, when it's exposed to the elements, this is the nail head, this part is going to rust, but it's going to protect the iron. So that nail's structural integrity will remain intact because it'll be the zinc that corrodes instead of the structural iron part. All right, 5, describe the electron flow. Describe the flow of electrons in a battery. What happens to the anode? What happens to the cathode? So electrons always flow from anode to cathode. Always. The reason for that is the electrons are being lost at the anode, and where are they going? They're going to the cathode. So you got to start with where they're leaving from and then end where they're ending up. So oxidation occurs at the anode. That's always where you start, and you end at the cathode. And what happens to the anode and the cathode? Well, the anode gets smaller, and the cathode gets bigger. The way I remember that is red cat, reduction at the cathode, gets fat. It grows. And why is that? Well, for example, in this one, we have Cu plus 2 getting reduced to become Cu 0. It's going to become the metal that attaches to the electrode, and it's going to grow. The longer that goes on, the more copper ions get reduced, the more get attached to that electrode, it gets bigger. All right, and that's it for that section. I hope you found that helpful. I'll see you in class. Okay, bye.